During our first meeting, we learned that a ray is a portion of a line that has been extended in one direction without end. It has one endpoint. I'm going to create two rays. Here is one, and here is another. Now watch what happens when we join the two rays together with a common endpoint. There we go. By doing this, I have created what's called an angle. This is a symbol for angle. The length of the rays is unimportant. I'll stretch the bottom ray. There, I made it bigger. Let's make it smaller. You see, the angle is unchanged. It's the area between the rays that determines the size of the angle. Angles are measured using the same unit of measure we use to calculate temperature. The term for this measuring unit is degrees. The mathematical tool used to measure the degrees in an angle is a protractor. And since we've got our shipment right here, I'll be able to show you how to use it. Notice that this protractor has two sets of numbers. Each set of numbers begins with 0 and ends with 180 degrees. I can begin here at 0, go to 180 degrees, or I can begin here at 0 and go back to 180 degrees. Each mark is 1 degree. The two sets of numbers allow us to measure from left to right or right to left. There are 4 different types or kinds of angles. An acute angle, a right angle, an obtuse angle, and a straight angle. Probably the most common type of angle that we see every day is the right angle. A right angle measures exactly 90 degrees and is indicated by this symbol. Here are some other examples. Now, take a look at this angle. The common endpoint of these two rays is called the vertex of the angle. We can identify this angle in 3 different ways. It can be called angle ABC, angle B, or angle CBA. The vertex is always the middle letter. I'll create a right angle now. I can take any piece of paper. It doesn't matter if it's rectangular or irregular in shape, like this one. I'll fold it so that I have a straight base or bottom. Now I'll fold the base over itself so that I have a straight base and a straight side. I have now created a right angle checker. By using a right angle checker, it's really easy to tell if angles are right, acute, or obtuse. An acute angle is an angle that measures less than 90 degrees. An obtuse angle measures more than 90 degrees, but less than 180 degrees. And a straight angle measures exactly 180 degrees. Look at these 3 angles. Let me show you how easy it is to discover what type of angle you have using the right angle checker. Using the vertex of my right angle checker, I will line it up with the vertex of angle ABC. Ray BC is also lined up with the checker. Since I cannot see ray BA, I know that my angle is less than 90 degrees. Now let's look at angle FED. Placing the vertex of the right angle checker on vertex E and ray ED, I can see that ray EF extends much further than the 90 degree angle. Therefore, I have an obtuse angle. Now, let's look at angle IHG. When I line up the vertex of my right-angled checker, I see that ray HI and ray HG also line up with the lines of my right angle. Therefore, I have another right angle. It's fun to measure and create angles. And speaking of creating angles, suppose your teacher wants you to construct a 65-degree angle. Piece of cake. Let me show you how. First, I construct a ray and label it BC. Now I will place the center of the protractor at point B, which is going to be my vertex. I will line up the protractor on ray BC. I will follow the outside edge of the protractor until I reach 65 degrees. I will place a point and label it A. Now, using the straight edge of my protractor, I will connect point A and point B. I have just constructed a 65-degree angle. Let's take another look at our map of Maptown, USA. I'll project it on the wall. Notice that most of our streets intersect and create right angles. For example, North Dividend Street intersects West Square Avenue and creates 4 right angles. South Addition Street intersects East Subtrahend Avenue and creates 4 more right angles. Lines which intersect and form right angles, such as these do, are said to be perpendicular. Notice that West Angle Way connects with Northeast Angle Way and creates an obtuse angle. That is, an angle greater than 90 degrees, but less than 180 degrees. Most streets, when they intersect or connect, create some type of angle. Now, let's learn to use the protractor, the instrument we use to measure or create angles. Look at angle ABC. I'm placing my protractor on ray BC. Now I'll look for the small hole at the center of the bottom of the protractor. After finding the hole, I'll position the protractor so that the hole is directly on the vertex B. Then I line it up so that the straight line extends from the hole on ray BC. Starting with the inside set of numbers, I'll follow the edge of the protractor until it meets ray BA. Look at the number that touches ray BA. It's halfway between 40 and 50. Therefore, the angle measures 45 degrees. If I had used the wrong set of numbers, it would read 135 degrees. This is when my right angle checker really comes in handy. Notice that the angle is less than 90 degrees. Therefore, I have an acute angle. Now let's look at angle DEF. E is the vertex. I'll place the whole of the protractor on the vertex E and line up the straight line of the protractor on ray EF. I'll follow the outside edge of the protractor until I come to ray ED. Notice ray ED does not extend to the edge of my protractor. That's not a problem. All I have to do is extend the length of the ray. Remember, it's not the length of the ray that determines the size of an angle. It's the area between the rays. Now, when I look at ray ED, I see that it is 120 degrees, which is an obtuse angle. Using my right angle checker again, I can see that when I line up my checker with the vertex E, the angle is bigger. It's often confusing to know which set of numbers to use, but if you use a checker, it's easy to tell if it's a right, acute, or obtuse angle. Then you know which set of numbers to use. Now it's time for... Here's what to remember. An acute angle measures less than 90 degrees. A right angle measures exactly 90 degrees. An obtuse angle is greater than 90 degrees, but less than 180 degrees. And a straight angle is exactly 180 degrees. Also remember that the length of the rays is unimportant. It's the area between the rays that determines the size of the angle. For today's follow-up activity, it would be nice if you could measure several angles and create angles of various degrees. You'll enjoy trying this on your own. Well, I had fun today. I hope you did too. I look forward to our next meeting when you'll learn how to use a compass. Right now, I'm off to check some angles in the old ball field. See you next time. Whoa!